Today we would like to demonstrate what we have as a programmable inverter that is here on campus, the Perth campus. I'm going to quickly go through different parts of the setup. We have firstly, an inverter is simply the inverter that can be used to convert power from photovoltaics to the grid, or the same inverter we use for electric vehicles, etc. It has different components or main components. One of the main components is the power module that we have here. This is the power module that we have from Semicron, and it has different semiconductor devices that you might be able to see the white blocks that we have on top of the heat sinks. They are the IGBTs, and they are simply semiconductor switches that they turn on and turn off, but they can turn on, turn off very fast, high switching frequency. To be able to turn them on and off, we need to send some signals with a specific voltage and current, and that happens through the gate driver boards that we can see here inside the module, the white gate drivers. And the switching signals for each of these devices are generated from a microprocessor that we have from Texas Instruments. The different components or different boards that we see here, they mainly are scaling up or scaling down the signal. So, for example, on switching signal, we have the microprocessor that generates switching signals, some digital outputs that they scale up to 15 volt, and they will be transferred to the devices. On the other side, we have some measurements, analog and digital measurements. Analog measurements for voltages come from these 4 boards, in which they scale down the voltage from, they can go up to 1000 volt, to they scale it down to maximum of 3 volt, and that makes it readable from the microprocessor. Same thing for measurement of the current. We have 2 boards here, and they use Hall effect sensors in which we can measure the current of a cable that is connected inside the sensor, similar to what we have here. And also in the setup, we have a HMI, in which enables us or the user to see some of the parameters that we have, some of the measurements that we have, or it also enables to send some command to the controller. The main setup originally is designed to drive a 100 kilovolt ampere inverter for energy storage applications, but it has been adapted for teaching and research purposes here. We can program our microprocessor using different software tools. One of the software tools that we have is Plex, in which it can simply get connected through the microprocessor using the USB cable, and we can use it to program different types of controller. And simply what we have here on the oscilloscope is a simple operation of an inverter, and what we see here is the output voltage, or the pulse width output voltage that we get from an inverter, and the input to our inverter, of course, is a DC voltage that is generated with this DC supply. And that's all from me. Thank you.
So hello everyone, my name is Alfonso Gabriel Quinte. I am a Master's of Electrical Systems student here. So I am on my last semester, and I did my thesis with this programmable inverter in our EIT laboratory. So the main topic of my thesis is the comparative analysis of the switching frequency of the inverter. So I compared the fixed switching frequency and variable random switching frequency through this oscilloscope. As we can see here, these are the harmonics that we produced, and I compared both of the switching frequency schemes, and that's it.
Hello, my name is Mario. I am studying my Master's of Engineering, Electrical Systems. So I will be working in this lab with some of the elements that we have here, and I will be working is the inverter, the controller, and also checking here all the signals. My project is related to PV systems. I will work with DC to DC converter basically, and I will be here for a while working on this lab. Thank you.